Welcome, friends. Let's take a look at analyzing this differential equation. We're going to apply the existence and uniqueness theorem. So let's see what happens. First, let's just solve it. So we have essentially dy dx is equal to y minus 1 over x. So you can separate the variables. You're going to have dy over y minus 1. This would be equal to, let's see, what is that? That would be dx over x. And then you anti-differentiate both sides. So dy over y minus 1 is equal to, let's see, the antiderivative of, let's see, dx over x. Okay. Now on the left side, the antiderivative there is just ln of the absolute value of y minus 1. On the right side, that antiderivative is just equal to ln of the absolute value of x plus c. That way. Now, it may not be obvious how to proceed from here. Well, one thing that you can do is you can do ln of y minus 1 minus ln of x equals c. That's allowed. And then you can use the property of logarithms that says it's ln of y minus 1 over x, you see, is equal to c. Then you can exponentiate both. On the left side now, we will get e and ln canceling off, which means you just bring down the absolute value bar. So you have y minus 1 over x. Let's try that again. So y minus 1 over x this way. And this is equal to e to the c. Now drop the bars, so you're going to have y minus 1 over x is equal to plus or minus, really, e to the c. So the convention is you just call this a single constant, like a, for example, is equal to this plus or minus e to the c. So it becomes simpler. Then it just becomes y minus 1 over x is equal to a, where a can be this quantity as positive, negative. Right, now solve this for y, so y would be equal to ax plus 1, this way. Now let's look at this solution, ax plus 1. First of all, notice something, that like if you try to do this, use the 0, 1 as a point that you want to go through, will that work? Well, let's see here. You're going to have 1 for y is equal to 0 times a plus 1. So now we will have 1 is equal to 1. Well, this is true, isn't it? Like this. So we have a solution that goes to the point 0, 1. No problem. Okay. Now, the question, though, is this the only solution that goes through there, or can we find some other solutions? Well, think about this for 1 second, okay? Because we are doing, let me do this one more time, 0, 1, then you have 1 is equal to 0 times a. Stop for a second. Look at this a right here. Because you're multiplying by 0, it doesn't really matter what the value of a is, does it? Think about that for 1 second. And then plus 1. In other words, if a is 1, then we would have y is equal to 1x plus 1. That works, no problem. Because when x is 0, y is 1, and you have 1 equals 1. If a is negative 1/2, guess what? That also works, because that would give you y equals negative 1/2 x plus 1. But that also works, again, because when x is 0, then 1/2 negative times 0 is 0. And when y is 1, you would end up with 1 being equal to 1. You see, it also works in the case of negative 1/2. In fact, you can repeat this for any value of a. Because of that, you can say there is no unique solution through the point 0, 1. So in terms of, for example, graphs, if I may show you a picture here, imagine we have 1x plus 1, okay? So that's a solution that goes through 0, 1. You see it goes right there. But just as well, you can have negative 1/2 x plus 1. That's also a solution that goes through there, no problem. Make up some other solution. Y is just equal, for example, to 1. That would also work because that's the case where a has the value 0. In other words, with a single point 0, 1, you can get infinitely many solutions. So kind of you should be focusing here, right? With a single point, you're getting infinitely many solutions. So there isn't a unique solution that makes the equation true. Now look at the next perspective here, okay? You have y prime equaling y minus 1 over x. Notice that at x equals 0 is another way of saying the y-axis, correct? Like y prime is not defined. So when you have that, because it will lead to division by 0, right? When you have that, then you have these kinds of issues. So that's why along the y-axis here, for example, we have through a single point infinitely many solutions, or no unique solution, or non-unique solutions, if you like. What else can happen? Well, choose some other point on the y-axis. Say the point 0, 2. Let's see what happens in this case. Okay, so plug it in and see whether you can find a in our solution. So this would be like saying 2 is equal to, let's see, a times 0 plus 1. Guess what, though? Look at it. Again, because a gets multiplied by 0, you have 2 equals 1. This is false, isn't it? Okay, so choose some other point somewhere else on the y-axis as a consequence. Okay, so let's say 0, negative 1. Okay, so some other point. I'll mark these in the graph in a second. So that would give you then, let's see, where were we? Yeah, it would be 1. Well, negative 1 is equal to a times 0 plus 1. Again, this would lead you to conclude that negative 1 equals 1, but this is again false, isn't it? False. Because of this, that means that through this point, right here, to that point, no solution. To that point, you see? To the point 0, 2, again, no solution. Let me mark it in the graph right here. 0, 2, again, no solution, you see? So because here in the definition of the slope, you have division by 0 when x is 0, that is, you're moving on the y-axis, essentially. That's where the slope is undefined. You see the consequences. You have one special point where you have infinitely many solutions through it. Then you have infinitely many other points along the y-axis where there is no solution because you have nonsensical claims arise from trying to find the value of a in this particular case. It always gets multiplied by 0, so it gets wiped away, and then that's it. Doesn't work. This was a kind of interesting problem. So, friends, please be sure to like, subscribe. Thank you so much for watching. I will see you in another video.